And it's all my pleasure to be here this morning and to talk about this very timely topic, AI, RAN, and open source. So by the way, I pick up two interesting data points in your information sharing. One is amongst the top 20 topic list, I found two edge computing topic there. Number 7, edge computing, version 1.0, and then 17. It's AI RAN, and edge computing is part of this AI RAN, so it's interesting. They are related some. Yeah, and the second interesting information was when you asked the ChatGPT, what are the most successful technologies? And then edge computing, surprisingly, is included. It could be a little bit controversial. But with the introduction of AI RAN, we have a higher chance to make this time much more impactful and successful and move the needle. Yeah. Maybe ChatGPT anticipate that, right? That's right. Yeah. So once again, my topic is, as you see, AI RAN and open source and building a scalable data pipeline. So I will delve into what the AI RAN is and how open source data pipeline and scalable AI infrastructures will redefine the future. So where's the clicker? Here. Okay. So I can skip it, and you already updated on that. So what is the AI RAN? So it is a next-generation telecom network architecture that integrates AI-driven intelligence into radio access network. And it leverages all this AI technology, machine learning, deep learning, reinforcement learning, Gen AI, LLM, now agentic AI to enhance the network performance, efficiency, and optimize network operations, resource allocations, and enable new edge services such as AI inferencing at the edge. And this is not just an upgrade of radio access network. It's a complete transformation of how we build, operate, and monetize the network. And how does AI RAN work? And AI RAN is built on a unified AI-powered computing platform. It's not only a GPU. I'm talking about GPU, CPU, NPU, all kinds of heterogeneous accelerated computing or centralized computing platform that efficiently handle both network functions and AI workloads. This means that AI RAN infrastructure can support AI-driven applications like real-time analytics and AI-powered network operational tasks such as automation and AI inferencing service. So a few words about the evolution path of AI RAN. So the current AI trend kicked up transforming the existing telecom network towards called AI native network. And the key driver behind is first, the TCO savings by maximizing the network efficiencies by AI, and second, new network monetizations by hosting edge AI services. And according to the market survey, there is an increasing demand for lower latency AI, mainly for quicker AI processing, facilitating both RAN use case and AI applications. So in response to this demand, and the second phase here, it's a deployment of edge AI cloud, which involves establishing a distributed AI processing node, and then followed by a third stage, which is a transformation of RAN, which means upgrading RAN into AI inferencing hub which will bring a new revenue stream to the service providers. And this will lead to the next stage, fourth stage, where AI is deeply integrated into more advanced networks, such as 5G advanced or even 6G. And as network becomes more advanced, this fifth stage involves the development of AI networks, AI native network components, where AI is going to be embedded at every component horizontally and vertically, and making the network inherently AI-driven. And then finally, the sixth stage on the far right, federated AI learning. So enables AI models to be trained across multiple distributed nodes without the need to centralize data. So let me give you some examples of AI machine learning models. You will hear about these examples throughout the day, especially from the presentation from China Mobile. And for example, in the 5G air interface, AI can improve radio link performance through channel state prediction and using the neural networks. And beamforming optimization can be enhanced, especially the messy MIMO use cases by AI. And reinforcement learning optimizes scheduling and handovers to ensure seamless mobility management. And AI-driven energy efficiency models, AI models, can dynamically adjust the transmission power of the radio, which will benefit a huge energy savings. And lastly, the layer 2 and layer 3 protocol stack, AI can predict handovers accurately using latest model, time series model, enabling proactive decision making for user mobility, and so on and so forth. So, and then this is, we can expand this AI machine learning use cases to the more operational side. So, OSS, operational supporting system, can also fully leverage, particularly, the reinforcement learning technologies to optimize the various aspects of RAN operation management and optimizations, which include the fault management, configuration management, accounting, performance security, etc. I don't need to explain. So getting into the main part. So I will talk about data for AI issues here from now on. So data management issue, and then data quality issue, and data integration issues. So starting with the data management issues, as shown in this chart, we face several key challenges that impact the effectiveness of AI model training. As you know, one of the major challenges is the data silos, so silo data, where data is fragmented across different departments and systems, and preventing the creation of unified AI strategies. Without seamless data integrations, AI models will struggle to deliver accurate insight and optimization across the network. So another critical issue is real-time processing. Radio access network is a real-time machine. So it's essential to, we support the, instant decision-making or real-time decision-makings. And the ability to process and analyze the live data, operational data in real time, ensures that network remains adaptive and responsive to changing conditions. And data ingestion and processing add further complexity as telecom networks generate a vast amount of data that needs to be collected, cleaned, structured before AI model can utilize it. And of course, there is a compliance and regulatory issues. So addressing all these challenges is absolutely critical for us to fully harness AI-driven capabilities. So where are the solutions? Addressing this require a very strategic and systematic approaches. First, breaking down the data silos by implementing a federated data integration platform powered by AI-driven data lakes. We can consolidate network data across departments, enabling seamless AI integrations. Next is deploying the edge AI at distributed locations and leveraging lower latency AI inferencing ensures that the network can respond dynamically to the changes and optimizing performance and efficiency. For AI models to deliver meaningful insights, data ingestion and pre-processing must be automated. AI-powered data pipeline, cleansing technologies, and synthetic data augmentation enhance data set quality, which I will address next slide, ensuring that AI models are trained with the best possible inputs. By the way, I don't have a timer. Yeah, okay. So finally, compliance, regulatory adherence cannot be overlooked. And next dimension is data quality challenges. This is even more critical. AI models depend on high-quality data sets as addressed by, just before, RPIT, here's the slide, to function effectively, but such data sets are very often scarce and rare in telecom networks, and making it so difficult to develop and deploy AI solutions at scale. And besides, the data privacy laws, such as the GDPR, impose strict regulations on data sharing and utilization and limiting the availability of data for AI training and analysis. So all in all, there is a sense of urgency. We have to do something, right? So luckily, as far as I know, today we have a very interesting announcement which will address this, urgent call for the industry. And the cost of data collection and annotation is another significant challenge, as it requires substantial resources and slowing down AI adoption. And additionally, raw data is often unstructured and network vendor-specific, and which require extensive processing, pre-processing before it can be used. So then, to address them in AI-RAN system developments, a multi-layered strategy is necessary, shown here. First, synthetic data generation can supplement real-world data sets, reducing dependencies on scarce operational data while ensuring privacy compliance with the regulations. Synthetic data itself is a big topic. There are some concern if you abuse the synthetic data too much, your model will collapse, or it's biased. But then good news is there's a lot of technological advancement to compensate that. So now with the Gen AI technologies, synthetic data quality is getting better, which is good. Next is federated learning allows AI training to occur across decentralized data sets without transferring raw data. An automated data pipeline can streamline data pre-processing, handling unstructured vendor-specific data efficiently. And AI-driven cleansing, labeling, augmentation ensures high-quality structured data set for model training and inferencing. And finally, collaborative open source data initiative can establish industry-wide standards for data set curation, annotation, sharing, while maintaining security and governance. Yeah, RP just announced that there will be a project called SEDM. So this could be a perfect solution, very timely. Last one, the integration challenges. one major issue is the gap between standard and real implementation by vendors, different vendors, which creates incompatibility issues. And different development priorities also pose a challenge, as there is often conflict between the priority conflict between operators, enterprise, AI specialists, or a service company, and even research institute, academia, so making it difficult to align effort or investment. And the testing complexity arises due to the need for seamless hardware-software alignment and CI/CD CT processes, which are crucial. Cloud-native hurdles add another layer of difficulty, as adapting the AI workload to cloud environment involves upgrading of existing orchestrator to cover the AI workload in addition to the traditional RAN workload, and do some trade-off between performance, scalability, and cost, especially edge AI infra cost. To address these integration challenges, several solutions appeared. First, telecom operators should implement a standardized API and compliance framework. We have a camera project here, so we can ask the camera community to work on it, and so that we can make a better alignment with both standard bodies, suppliers, and any other stakeholders. And development priorities can be streamlined by fostering collaboration between industry, academia, ensuring AI research priority aligned with the practical telecom needs. So to overcome testing complexities, we need to deploy automated CI/CD CT pipelines as a part of MLOps or AI ops, and AI-driven validation tools to ensure smooth integrations. And network digital twin can play an important role in this course. For cloud-native hurdles, AI workload should be orchestrated together with the RAN, traditional network function workload, and optimized for distributed environments, leveraging containerizations, orchestration like Kubernetes. And finally, this chart shows overall, I would say, data for AI platform. It's a framework for data for AI or AI RAN. So getting into more details, we have on the bottom, data ingestion layer. AI RAN systems require continuous ingestion of network data, including real-time telemetry, performance metrics, event logs from distributed network equipments. Ability to handle both batch and streaming data is essential for optimizing AI models that dynamically manage network resources. One level above, we have storage and processing. In AI RAN, network data needs to be efficiently stored and processed to remove noise, and handling the missing values, normalize the data sets for training, for machine AI model training. So this will ensure that AI model will be trained on high quality and the most relevant data. One layer above, we have a transformation and modeling. And data transformation include feature extraction, data augmentation, structuring the data into meaningful formats. AI RAN models must be optimized for RAN domain-specific tasks, such as, for example, beamforming, handover, prediction, interference mitigation, and network automations, etc. And on top, we have a model prototyping before deployment, just before deployment. AI RAN model undergo prototyping and validation, assess their impact on network performance. So this step is crucial to ensure the models are robust enough and can generalize across diverse network environment. And the most importantly, do not disrupting the live network operations. If it happens, it's going to be a nightmare for operator. And then model deployment and serving. Once validated, AI models must be deployed at network edge through the various deployment tools. And recently, a lot of AI platform companies, they announced their own deployment tools. Recently, NVIDIA announced called the Dynamo, which is an inferencing platform. And AI requires lower latency inferencing, meaning models should be optimized for real-time decision making. Finally, AI ops, ML ops, you name it, LLM ops, data ops, and federated governance needs to be put in place. But adopting this structured AI platform, AI for data for AI platform, AI RAN can be significantly enhanced in terms of network automation and optimization and intelligent resource allocation, leading to a higher network efficiency, lower energy consumptions, and improved user experience. And final remarks from my side, open source ecosystem has been fostering a continuously the software development environments and ensuring AI evolves to meet the demands of various stakeholders. So compared to proprietary solutions, which often require expensive licenses and vendor lock-in, the open source tools offer more economically viable alternative while providing at least the on-par capabilities or even superior than the commercial solutions. And transparency in open source AI ensures accountability and ethical AI developments. So Arpit, once again, he introduced, it's a new project, Salas. Is that correct? Salas, right? So this openness helps mitigate biases, enhance the security, and promote responsible AI usage, leading to more trustworthy and ethical AI-driven systems. Okay, with that, thank you for your attention and enjoy the rest of the event. Thank you.